In this video, we will continue our discussion of section 11.5. We are going to talk about finding an angle between a line and a plane, and then also how to find the intersection of a line and a plane. So I drew a picture here. This picture, let me make this line red, but P here is my plane, sideways, right? We're just looking at an angle. And then I have the orange line, and we're trying to find phi there in the middle. And we want to use what we know. So I do want to mention something here because, okay, so if I'm trying to find an angle, okay, I can create a vector here on V or on L, and we'll call it V, right? There's my vector V. It's just in the direction of L. I could use this definition, cosine, and I'm going to leave that blank for a minute, okay, and I would take V, and I would dot it with N, and then I would take their magnitudes, and use that definition, right, to find angle between the two vectors. Now, but if I'm trying to find the angles of the two vectors, it's kind of misleading here. This is in here, and then V is the red vector to the right. So the angle we'd actually be finding in between is there. Let's call that theta, right? Well, theta here, if I solve for it, is the inverse cosine of this mess. So if I wanted to find phi would be 90. Oh, well, let's think about the triangle here. Think about 90 degrees, right? This is a 90-degree angle, so the other two, if I call this theta and phi must make up 90. So if I take 90 degrees, let's put a theta here. If I want theta, I just take 90 degrees. No, forgive me. Okay. We have theta. Let me start over. We found theta. The reason we don't have the phi is because the angle between N and V is right there that I highlighted. It is theta. Now, that makes a triangle right in there, and I know that theta and phi make up 90 degrees. Theta plus phi is 90 degrees, right? So if I wanted to solve for phi, I would just take 90 degrees and minus theta. So we have what theta is. It's right here. So we would find the angle. So here's the key to these. Find normal vector to plane. I'll say normal vector N to plane. Find directional vector of line. Find theta, angle between. And then the last thing, and we'll put this here. Find phi, which is 90 minus theta. There you go. All right, intersection, that's how you find an angle between a plane and a line. Intersection of a line and a plane, how we find those is we plug, and I'll do an example of this one, plug line into plane. All right, so let's take a look at this example so I can give you some what I mean by plug line into plane. All right, it says find the point of intersection of the following plane and line. I have the plane up top, I have the line. Notice that there are variables here for the plane, usually x, y, and z. We only have an x. So what I'm going to do is take that x, and I'm going to plug in its definition from the line. 1 plus 4t plus 3, and I do the same thing for y, equals negative 5. And now we solve this for t. Out. Okay, so we get 14t. I'm going to minus 2. So we get t is negative 1/2. Now, that doesn't tell me the point. That tells me when it happens on my line. So if I plug that into x, y, and z, so x equals 1 plus 4 times negative 1/2, we get negative 1. If I plug in that into my y, 2 times negative 1/2, I get negative 1. And then z, I plug in negative 1/2, I get 3 plus 6 times negative 1/2, and we actually end up getting 0. So the point of intersection between this plane and this line is -1, -1, 0. Pretty easy to find when you plug it in. I feel like these are the most straightforward, less thinking type problems of finding intersections. The other ones involve a lot of vectors, while this one is just straight algebra.